Hey, let's see if we can do 3 examples of completing the square and how it can help us solve an integral. First, let's take a look at our situation up here. And I just want to point out, I've said this before, but I actually want to show that u substitution doesn't work. Here's why. If I plug in what you would expect to be u and found du over dx, and then solve for dx, you'll notice my integral has x's in it and it has u's in it, and that's just not working out so well. If I have a du here, that variable of integration, that means everything should be written in terms of u right now. Shouldn't be any other variables in there, so that's not going to work. Let's just take care of that. Bye. So we have to use this whole completing the square thing. So I want you to take a close look at the denominator there and see, can you complete the square? We're going to try and half it, square it, and send it. Notice I'm going to kind of separate the 10. I'm going to move it over a little bit. Take half of 6, square that number, and then we can't add it to both sides because there's no equation there, but we're going to add it and subtract it. If I take half of 6, I get 3. 3 squared is 9. If I add 9 and subtract 9 in the same place, there's a net gain of 0. But we do have a perfect square. So see what happens here. Now we have an inverse tangent. Look at that, u squared plus a squared. I'm going to move out of the way so that you can see the actual integral rule over there, but I take 1 over a is just 1, and then I take u divided by a. I mentioned a is just 1. There we go, we have the answer. We use completing the square to rewrite part of it as u squared, and so that's actually going to show us that we can use the inverse tangent rule. Let's try and get through maybe 2 more examples. This one seems appropriate here. There's another example, and we are going to try and complete the square, but we have a little issue right now. Which function is this going to look like? Which integral rule do you think we're going to need to use? There seems to be a square root that narrows it down. Are we taking a variable minus something or a number minus a variable? We're going to find out in just a moment. Before I complete the square though, let's rewrite the inside just a little bit. If I factor out a negative sign, that's going to make this a little more obvious. Here when we complete the square, half it, that's 2, square it, and then send it. Except it appears that I've added 4 in 2 places. Is that okay? No, it wouldn't be. But technically, don't forget there's a negative sign out in front of these parentheses. This, inside the parentheses, is really minus 4. So while it looks like a plus 4 here, when you actually distribute the negative sign, this is a negative 4 and this is a positive 4. The net gain, once again, is 0. So from here on out, it gets a lot easier. Rewrite this equation, maybe back with this marker. You keeping track of this at home? Do you get it? Do you got it? Do you see it? It looks like an arc sine function. A is going to be equal to 2. U is going to be equal to x plus 2. And now we have arc sine of u over a plus c. By the way, I lied. I don't think I really want to give you another example. I think 2 is going to be fine. There's not going to be that many problems like this, but if you know how to complete the square and you can identify which form to use, you're going to be just fine. Thank you.